All right. Good morning. Morning, class. For all those people that decide to come to school and class on time.
He's on his way.
Do you know what? Listen, lies. Okay, lies. I might see him by advisory. Anyway, all right. Fundamental theories calculus. You will see this often, and it is commonly referred to as FTC 1 or 2. FTC 1 and 2. So, fundamental theory of calculus, part 1, let f be a function that is continuous on a closed interval. The function I defined by this from a to x, which is some value, okay, and it's going to be f of t dt. That means that I am actually taking the integration or antiderivative in what terms? Watch here. What terms am I taking the antiderivative of?
What time?
Yes, t. Okay. In terms of t, not what time, but yes, t. Okay, thank you. All right, has properties continuous from a to b, okay, and is differentiable on a to b. So what does that mean? Yes, what does differentiable mean?
You can take the derivative.
You could take a derivative but to take a derivative, what has to happen for it to be able to take a derivative? It's got to be continuous, and what else? No pointy point, right? Okay, now what was that thing called? There's a special word for it.
The cusp.
A cusp, there we go. Okay, has to be a cusp, and, okay, so it's got to be continuous and all that good stuff, right? Okay, so has the properties that it is continuous from a to b and differentiable, blah, blah. Okay, that I prime, which means I'm taking the derivative of the integral. The derivative of the integral, or let me reword this, the derivative of the antiderivative.
So just the function?
There we go. Bam! There's just the function. And so you're going to end up with, okay, for all of x, it's just going to change it to become f of x, which is my top bound. If you notice that? Look closely at it. Okay, x is on the top. That's my top bound, right?
Oh.
Okay, that's where my b would be normally, right? From a to b. Okay, so from that one right there, so when we take the derivative of the antiderivative, okay, and so in terms of x, if you notice, it automatically goes to the f of x. So we have the function. So it's canceling out the antiderivative when I take the derivative, so I'm left with just the function. Okay. So, that's super good. So, FTC Part 1, Fundamental Theory of Calculus Part 1 means we're doing the exact same thing. So, here's two different examples where it happens. So, now, in this case right here, look at what I'm taking a derivative in terms of. So, if I'm looking at this, it is in terms of what? T, right? But when I take the antiderivative, it is of x, which is my, no, don't mess up, okay, which is my top bound right here, right? Okay, so from here it goes right there, and I'm replacing t with x, and I'm left with the function there. Okay, now does the same thing here. So this is going to be ds, right? When I have in terms of s, but now I'm doing it as x, which is going to end up becoming, okay, in terms of x, is going to be right there. Now, if you think about it, if I take a derivative of something and it's not the variable, what happens?
0.
0. It drops off, right? So if it's not the term, so it's not the x in this case, doesn't that just drop off? I'm taking the derivative of something that's like, 2x plus 3. And if I take the derivative, the 3 drops off. That's what we're talking about there. Because when I plug in 2 for all of this right here, that's all going to be one constant number. But when I take the derivative, doesn't all that just go away? There we go. All that's going to go away. So this could be an a value down here also, where it's not in terms that I'm looking for, which that's the one I'm going to be looking for, because this says a ddx, the derivative in terms of x. So that's what I'm looking for there, and I'm going to end up with this. Okay, now this one right here, same thing. So now for this one right here, slightly different. Slightly different. Okay, because what rule do I have to use?
Chain.
I heard it.
Chain rule.
Yeah, chain rule. Why chain rule? Yeah, because I have the derivative of something that I'm going to plug in, right? So this is a chain rule. This is a chain rule right here. So now, you know it's a chain rule. I want you to try it. I want to see what you guys can come up with.
Is this DT outside?
Yep, the dx is, yeah, it's dx of the whole thing. And the t is inside the radical though.
But that thing too.
Yeah, dt means it's in terms of this.
Okay, so it's outside.
Yeah, this is dt is outside.
Okay.
Get to work, slacker. Didn't you promise me 7:15 this morning? All right. Okay, anyone got an answer yet? Okay. Anyone want to take a stab at it?
Sure. Is it square root e to the 3x squared plus 1? Yeah, I know it's wrong, but plus 3x squared plus 1.
Okay.
I think it's wrong.
Not completely.
Not completely. Okay, that's better.
Didn't I say chain rule?
Yes.
Oh, so then the inside of
And
the
then from there we use chain rule?
Oh.
Times?
Times what?
6x?
Wow. We did it, guys.
Good job.
We did it. We did it. We did it. Hooray, yeah, we did it.
Oh, yeah.
But there's a switch.
No E. See?
Now we say.
I know you guys have it. You just got to be able to put it together. Okay? So we know it's a chain rule. There we go. So we plug it in for t because that's what we learned, right? And then times the derivative because that's what we got to do for the chain rule because that's anything other than just x by itself. There we go.
Oh.
Now, you have to use what I taught you. What were we working on when Dr. Garrett was here? Was that 5.2 still?
Yeah.
Okay, so yeah, check out your 5.2 notes. You could do this also. You can do this also, but we have to use the information. Okay? All right, look at 5.2. Look at 5.2. You got this. Okay, when Dr. Garrett was here, okay, I went over something. I said, hey, this is super important.
Yeah, what were you gonna ask me? Do you remember when you yeah. Do you remember all these questions? Is it the fourth slide?
Maybe. Would the fourth slide apply?
Do we just make it negative?
Hey, maybe.
Oh no, I cannot apply my 5.2 notes. You have to do.
The ones that I don't know what you like. I think Lucy has one, because it was just my notes on accident, for some reason.
She's not here today. Carter, do you have 5.2 notes? He didn't even take it out.
Because Carter is intellectual and remembers things.
Yeah.
Here's 5.2.
He has a reading.
We have more 5.2 here.
More reading.
Remember 5.2 was only one page.
Sure. 3 plus 2 is 5, right?
Yes. Carter, do you have 5.2 notes?
I'm telling you, it was only one page.
Alright, so what is 340?
Odysseus.
Yes.
I have another copy here.
Oh, cool, but I don't have the notes on it, though.
Okay, but maybe it's actually in there.
Oh, it's already on there?
Okay.
Oh, no, it's not.
Maybe it is.
One of them
Oh, I don't know.
guaranteed definite integral exists. Oh. You just switch it up.
All right. Okay, are we ready? We
Yeah.
ready?
I get it.
We're ready. All right, let's see what we got. So, go ahead.
I don't know.
Negative
Okay.
quantity in x to the third to the fourth.
Okay.
Whoa, whoa.
I don't know if I did that.
Okay. So I'm agreeing with you here. So it said x to the third raised to the.
Four.
Very good.
Plus 1.
To the 1/3.
Yeah.
Good job.
No, there's still the derivative.
Times 3x squared.
No, x squared.
X squared?
3x squared.
3x squared.
What's that? Bad at math.
Good job. Remembering all parts on that. Okay, where'd that negative come from?
You
The
got
rule.
Yeah, we switched.
There was a rule. So if we are taking this and we got to flip it over, right?
Yeah, you put
We
it-
got to flip it over because I want my x cubed on top, and so I negate my integral first. So I negate my integral, then when I go ahead and plug it in. So now, if I clean this up, that would be x to the
12.
12th, right? Okay, x to the 12th, very good. So that would be clean and then times this. Now, AP, leave it messy. That's fine. That's your answer.
Yay.
Okay, leave it messy. Usually when you simplify it, you're probably going to mess it up a little bit. So don't do that. That's a nice. Okay, fundamental theory of calculus part 2. Let a function f be continuous on a closed interval from a to b. If capital F is any antiderivative of f on a to b, then it could be the antiderivative of the top minus the antiderivative of the bottom. So what we're going to do is take the antiderivative, plug in the top, and then minus the antiderivative with the bottom plugged in. And that's going to give me my total right there. So while we're doing this, yeah, we were doing this before, right? We have been doing this, and it's always the top minus the bottom, right? Yeah, it's always going to be the top minus the bottom. And like I said before, you know what? Eventually, you know how we kept adding on my antiderivative? We add the c onto it, right? So if we do this, we're adding a c and they're minusing a c, right? So this is FTC 2, Fundamental Theory of Calculus Part 2. And so this makes your math a lot easier. It really does. Sometimes you're actually